Welcome back to our NSEA astronomy practice session. In this video, we will solve some important multiple choice questions on celestial mechanics and stellar distances. These questions are excellent for strengthening your fundamentals of parallax, Kepler's laws, orbital motion, and astronomical distance scales. After each question, I will reveal the correct answer along with explanation. Before we start solving the questions, let's quickly revise some key concepts. Parallax helps us measure distances to nearby stars. The distance in parsecs is simply the reciprocal of the parallax in arcseconds. In other words, distance equals 1 divided by the parallax. Next, Kepler's laws describe planetary motion. Planets move in elliptical orbits, sweep out equal areas in equal times, and their orbital periods squared are proportional to the cube of the semi-major axis. For numerical problems, we often use the ratio formula. The square of one planet's period over the square of another equals the cube of its semi-major axis over the cube of the other. The orbital speed of a planet can also be calculated as the circumference of its orbit divided by the orbital period. Another useful concept is angular diameter, which tells us how large a celestial object appears from Earth. It is calculated as the object's physical diameter divided by its distance, and it helps determine the apparent size of planets or stars in the sky. Finally, some important celestial distance units. 1 astronomical unit, or AU, is the average distance between Earth and the Sun, and 1 parsec is equivalent to about 3.26 light years. With these basics in mind, we are ready to solve the questions. Question 1. A nearby star, Alpha Centauri, subtends a parallax angle of 0.7420 arcsecond. The distance to Alpha Centauri from us is A. 1.35 parsec, B. 13.5 parsec, C. 0.742 parsec, D. 7.42 parsec. Correct answer is A. 1.35 parsec. The distance to a star in parsecs is the reciprocal of its parallax in arcseconds. Using the formula distance equals 1 divided by the parallax, we have distance is equal to 1 divided by 0.742, which equals approximately 1.35 parsec. Remember, a smaller parallax means a larger distance, so stars farther away appear to shift less against the background. Question 2. A new planet is discovered orbiting a sun-like star in a circular orbit. It completes 1 revolution in 3 months. Approximately what is its average distance from the star? A. 3 astronomical unit, B. 0.4 astronomical unit, C. 0.125 astronomical unit, D. 1.25 astronomical unit. Correct answer is B, 0.4 astronomical unit. We use Kepler's third law, which states the square of a planet's orbital period is directly proportional to the cube of the semi-major axis of its orbit. Here the period t is 0.25 year. Apply it in the formula to get orbital distance of about 0.4 astronomical unit. Question 3. If a star has a parallax of 1/8 of an arcsecond, its distance from Earth is A. 2,06,265 astronomical unit, B. 8 light year, C. 1/8 parsec, D. 8 parsec. Correct answer is D. 8 parsec. Apply the parallax formula. Distance in parsecs is 1 divided by the parallax in arcseconds. 1 divided by 1/8 gives 8 parsec. Question 4. A planet orbits the Sun at a distance of 4 astronomical unit. The orbital speed and orbital period of the planet are approximately A. Orbital speed 7.92 kilometers per second, B. Orbital speed 14.93 kilometers per second, C. Period 4 year, D. Period 8 year. Correct answers are B and D. Use Kepler's third law for orbital period and orbital speed formula. At 4 astronomical units, the period comes out to about 8 years. The orbital speed, calculated as circumference divided by period, gives about 14.93 kilometers per second. Question 5. Venus has a radius of 6,052 kilometers and orbits at 0.72 astronomical unit. During a transit, the angular diameter of Venus as seen from Earth is approximately A. 60 arcsecond, B. 30 arcsecond, C. 0.6 arcsecond, D. 1.2 arcsecond neat. Correct answer is A. 60 arcsecond. We calculate angular diameter using the concept: the apparent size of an object equals its physical diameter divided by its distance from the observer. Here, Venus's actual diameter is divided by its distance from Earth, giving an apparent angular size of about 60 arcseconds, or 1 arc minute. Great job! You have completed astronomy MCQs on parallax, orbital motion, and distance measurement. Make sure to practice these formulas regularly, as they form the core of NSEA numerical reasoning. If you want more mock tests, PYQs, and concept explainers, don't forget to like, share, and subscribe. Until next time, keep exploring the universe.